Will it go like the woolly mammoth, or the weirdo, or like the batsman's warbler, disappeared like the melting snow? It's just to catch the buffalo. 2 weeks just to catch the buffalo. Some things take time, I know they do. Some things take time, I know they do. I hope our time will never go. A couple years ago, we covered one of the auctions for Prop Store, like we do, and one of the items being auctioned was the elevator panel from the movie Elf. In the movie Elf, the main character, our hero, the protagonist, he goes to the Empire State Building, and they push the observation deck door button, and he sees the button light up and goes, oh, and he pushes all the buttons and they all light up. Super, super understandable. I had twins. I spent years negotiating with 2 small kids about who gets to push the elevator button. So I totally connect and understand that drive. And the panel that was made was really, really, really beautiful. A spectacularly gorgeous panel, big stainless steel in Art Deco style with cutouts and cut-ins, 81 buttons. And I've been thinking for years, like, I want to make one. I really, really want one of these in the house. I want to hang it on the wall so I can touch the buttons, reset it, touch the buttons again. I actually want 2 modes for mine. I want to do it so that you can touch the buttons and they light up and touch them again and they go dark, or I want a single latch where they all go on and then you reset. I'm getting ahead of myself. When I was at Prop Store, I took some close-up pictures of the backside of the button panel and discovered that they were made by Dewhurst, aka Dupar, D-U-P-A-R, a elevator equipment manufacturer in Canada. And I reached out to them and we made a deal for enough buttons for me to make my elevator panel. And I'm about to open. They sent me 1 sample buttons while they're fulfilling my order so that I could start to do my design work. Elevator buttons come with electronics to interface them with the elevator system. Those electronics are actually even more than the buttons, and they're more than I need. So I just bought the buttons on the assumption that building an 81 button all separated latching circuit is a doable thing. I'm pretty sure it is. So we're gonna crack this. Oh. Oh, they put it in a thing. They even included, oh, this is freaking super, super awesome. Okay, great. So it's a 24-volt system. All right, shall we plug this in? They've done one thing. All right, let's try. Actually, before I get into the elevator button stuff, let's just plug this in. Guess it doesn't matter which ones it goes into. Right, there we go. Okay, so this is a classic momentary button circuit. And then it goes on when you push it and it goes off when you release it. And elevator buttons here, there's a pair of little momentary switches there that on either side, and there is an LED light in the middle. And I'll take this apart and cover it, but 24 volts, this is great. This is so great. Here's the Here is the super cool thing about elevator buttons. You've heard of the term planned obsolescence. If you haven't, look it up because it's messed up and a kind of amazing feature of modern society. The story or the modern story of planned obsolescence begins with a light bulb cartel. All these different manufacturers were making light bulbs in the early part of the 20th century, and they realized, basically, they formed a cartel to agree with each other that no one would let their light bulbs last longer than 20,000 hours. I think it's 20,000 hours. And this means that everything that you use in your life has a tested use limit that has been tested by the manufacturer. So, for a standard USB-A connector here is rated for a total of like 1,500. Is it 1,500? See, now I just forgot. Hold on, let me get my life. Yeah, standard USB-A connector here that has been tested to reliably survive 1,500 insertions. That doesn't sound like a lot, does it? 1,500. 1,500 times unplugging it, plugging it in. Once a day, that gets you about 5 years. 4 years, give or take. Four and change. 1,500, right? Like, really? 1,500? And then I did some research. Mini USB. Remember those? The mini USB, 5,000 insertions. Micro and USB-C, 10,000 insertions. So you see how much more robust USB-C and USB micro is and why we phased them out. And for reference, a standard wall switch on your wall. Now there's a wide variance of quality in there. However, the Underwriters Laboratories listings, I think, are pretty consistent, and out of a standard home wall switch, you can expect a life cycle of between 50 and 100,000 switch operations before a failure. Frankly, likely longer, but these are some of the metrics by which these things have been tested and can survive. So USB-A, 1,500, USB Mini, 5,000, micro USB-C, 10,000, wall switch, 50 to 100,000 cycles. Your standard Dupar elevator switch, 7 million cycles. 7 million. Yeah, right? Like, whoa! Because these are big, expensive machines, and people get in them, and people are abusive. And this right here is a small bit of equipment that is the spear point of decades of development of robust human interaction equipment. Robust equipment that interacts with humans. 7 million cycles, give or take, before failure. I think that's pretty freaking cool. So 81 of these, correctly numbered, are on their way here to the cave. I'm also ordering some stainless steel plate. I'm gonna chuck it up on my mill. I'm gonna drill all the holes. It's spectacular. I'm like so excited. And I needed this button specifically to start working out the rudiments of my latching circuit, how I was gonna do it. I think I'm gonna use solid state relay banks. I think I found some that were up to 16 relays that allow me to adjust what the reaction is when I hit a momentary. But also, I want to measure the size of the hole in the stainless plate so I can order some annular cutters or the proper cutters I need to cut all 81 of those holes. And I need a bunch of wire and stuff. So yeah, there's a lot of little things to do. This is a big, busy work execution. But it begins here. Boom. The elevator has arrived. All right, here's how simple this lovely thing is. You know how at the hardware store, they say the bulbs are rated to 100,000 hours, but they don't mean the circuits. The circuits usually fail before the LED bulbs. This isn't one of those. Just two nice bright LEDs, 24 volts. That clips in here. And yeah. So we're gonna pull this out. And there, yep. Right, studs put in there. And here is the button and its surround. Here you have your two normally open contact switches here. And if I actually pull the light, you can actually see how low the travel is. It's very little travel. That's actually probably by design to limit the amount of wear and tear. Amazing. There it is. There's my baby. Boom. All right. I love that they glued some 9-volt batteries to this for me. That was very sweet. 1.385. That's probably 1.375. And let's see if I possess one of those. Yeah, let's give or take 1.375. There you go. 1 3/8. That's the one. I'm going to order another couple of these. Elevators are mounted in stainless steel plates. It's usually, the elevator spec is a 300 series or 400 series stainless steel sheet. Those numbers, 300 series, 400 series, delineate different alloys of stainless steel. I was attempting to find, well, we have a company here in San Francisco that just delivers metals to your cut size. And I wanted to get some sheets of 430 stainless because it's easier to machine. That's a 400 series with properties that make it ductile and machinable. And the 300 series are not as machinable as the 400 series. But the 400 series are rare. They're harder to find. Anyway, I was running into trouble, and then I remembered that my friend Kevin Binkert of Standard Metal Products here in San Francisco has a giant water cutter. You might remember Kevin. He was on Prototype This. He's an OG member of Survival Research Labs and an amazing engineer and a longtime friend. I've known Kevin for over 30 years. And he's got a water cutter. So I texted him a picture of the elevator, and I was like, you can cut something like this out, right? And he was like, yeah, all day long. So I'm about to make a drawing of the dead nuts dimensions of what I've got about the ELF elevator. Yeah, that's just, I thought it would be instructive. Oh, it's a very exciting time. My elevator buttons have all arrived from Dupar, makers of the elevator buttons from the film Elf. And I was just at storage. I didn't know when these were coming in, but I've been very excited. And so, let's see what we... Oh, dude. Look at that. Look at how they do it. Oh, it's such a thing. Oh, ladies and gentlemen. Amazing. I'm so excited. Here we go. Okay. Hi, everybody. I have just been over to my friend Kevin's shop. My friend Kevin is the artisan maker who did the cutting out of my elevator button panel for me. And I reached out to Kevin because I think I talked about this already. This project goes on so long, I can't remember what I've said before or not. But basically, the elevator buttons that are held onto this panel are held on with studs, and I called up Kevin and I was like, I need the second panel so I can add some studs. And he's like, you need a stud welder? I've got a stud welder. We can put the studs on. So ladies and gentlemen, and everybody else, ooh, Studley, Studerific, Stud Zone. I don't know what the hell's going on in my head. This is great. This means that we can now progress to the next stage of elevator construction, which is great. And I'm gonna clear this workbench just to muck around with it. So they sent me one of their security locks, which is a barrel lock. I don't want to use that because it's more accurate. This is the accurate lock for the ELF elevator panel. So this is one I'm going to use. I believe this has off-on inspection, which is great. Actually, let's just check out one more. I have, nope. Yeah. Okay. All right, this is the correct one. So we're going to muck with this. So. I can't tell you how much this. Sorry, I can't tell you how much this pleases me. The buttons are all in. They have all been oriented correctly. I am using their studs that they're held in by to actually hold in a rigidifying framework that I have designed out of 3/4 inch birch ply, this stuff. I am going to make the box that holds this. I'm going to make it I'm sorry. I'm going to make it 2.5 inches deep, and I may actually lower the amount of that depth later, but right now that's like the most I can imagine I will need. And then I can get the engineering of this correct with 4 1032 flathead screws holding on each side, plus yeah, I think a couple of just rivets out here. Yeah, how about that? All right, so now I've got to cut. Now I have to, hi. Now I have to cut these strips. 2 strips, 2 Yeah. All right. We'll cut them to length and then we'll figure out what the insides and the outsides are. Oh, no. So, the whole idea behind this frame is that it uses the existing structure without me having to do too much gluing, and I can still take this entire thing apart, which I still need to do. I need to chamfer the front edges of this thing, but with the buttons in it and the all right. It's awesome! The frame is good. It installs and deinstalls easily, which was my main deal. So then, I still may make it shorter, I still may make it thinner this way, but I want to account for these wings, so I've cut this pair of pieces of plywood to create a space there. Yeah, there we go. Excellent. I am going to glue and staple that in from the inside. Then I'm going to pull this frame. I'm going to add some Bondo and spackle and give it a coat of paint, black paint. I want it to disappear. That's the goal. All right. This operation was one of the more delicate, actually. I chamfered the edges so that the corner came to a 45. And I did it with this little air tool. We'll include a link in the description. This is from Amazon. And I would not have bought this tool. I did not know how useful this was until my friend Kevin was like, dude, you got to get the chamfering air tool. It's amazing. Clouds roll upon the skies. Their silent thunder matches mine. I know these feelings from longing ago. I know what's coming in, you regret it. Lots of tedious, repetitive work on a job like this. I've got 81 of something, which means everything I'm gonna do is a multiple. But we're gonna put in all of the side screws now, because I think this might be the last time I assemble it like this. We shall see. There's still some work to do, obvi, but to be or not to be. All right. That is that and that and that. And let's stretch 'em on. So, work proceeds on the elevator panel. I'm calling this the joy panel. I have an issue. And the issue is that, there you go. Let's get this to you straight. Hang on just a second. So, see that? That's an LED. The original buttons for the ELF elevator panel were incandescent. Not that I want to go to incandescent. LED is nice and draws low power. But it's cold. It's a chilly light. Look at that. It's a stingy light. And I want it to be warmer. So I have some gel here. And it's fairly... Look, I mean, part of the robustness of this system is that they make the components incredibly easy to move in and out. It's spectacular. So what I can easily do is add just a tiny bit of yellow gel to the front of these two LEDs and pop them back in here and get the color that I'm looking for. But that's what I'm about to do. I'm about to figure out what the color is. I've got two gels here. I think I've got a 212 and a 149 quarter straw. And I even have this one, which is a little more orange, but it is a, what is this? This is an 1/8 straw, yeah. So I'm gonna play around with a couple of options. I'm gonna put you in a better position to be able to see the buttons, and then we'll go. Then we bring the negative from here to here. And send. From here, negative to positive, and then negative comes over here, and these should all three light up. Let's just double check. Hey, that happened. Oh, baby! Oh, baby! My heart is full of love and desire for you. Woo! Huh. All right. I think that looks like what I wanted it to. I think that's a beautiful color. Let's double check our voltage. Make sure we're exactly at 24. Yep, 23.98. Okay. That's great, everybody. The 212 is what I'm going to use. This will make these suitable. That's not working. I have gelled all 84-ish bulbs. I'm going to include a little glassine bag with some extra gels, label them Roscoe 212s, and tape it on the inside here. Always a good idea to do this kind of thing. But next is to do, right. So because we're wiring this, wiring will get an introduction in just a second. But when you're wiring up a bunch of lights like this, you don't need to send 2 wires to every single light. Like 2 separate wires. I'm going to be ganging up all the grounds, all the negative leads on all of these LEDs. And I have this spectacular jumper cable, which is just a bunch of jumped lugs. And we're about to install it. I'm going to disconnect my leads here. I'm going to unplug the power supply. And we are going... This is where setting up all your persuasions so that they're, like, I took the time to make sure every single button had the same orientation. Okay, there's 2 orientations of buttons here. Side and horizontal and vertical. And in laying those out, I made sure that all the horizontals were facing the same way and all the verticals were staying the same way. And that means that I can quickly check the wiring visually and not get too lost. We're just going to keep on buttoning this in. Later on, I'll come back in and sweep these with the positive lead, and anything that doesn't light up, I'll just have to reverse its polarity, but it should all, yeah, this is very testable. It's a very testable setup. It also means that all the distances my jumpers have to jump are consistent. They don't have to do a double jump at any given time. I don't know why Otto from The Simpsons is always my, like, go-to. You know how they have those, like, double guitars? All right, let's, right, so that should be connected. Wait a second. Hold on. I see, I've wired it all backwards. I understand it all completely backwards. No, I've just, gotcha. I can't stress enough that I don't know much about electronics. I'm pretty electronically ignorant in a lot of ways, but I know to test my systems constantly. Okay, now I gotta get a little extension on this puppy. Excellent. Okay, all the bulbs light up correctly. So I can unplug that and let that chill. All the plugs are in the right places. And, all right, so now I need to pop in a panel here. It's like about like this. And this will be where my 5 boards go. 1, 2, 3, 4, 5. I'll have them on standoffs, but I'm also going to be holding this on with a hinge. With everything in place, it's now time to wire it. And when you want a light to stay on when you hit it, that is, for all the reasons that make sense, called a latching circuit. And a latching circuit does exactly what it sounds like. It latches when you apply power to it, and then can be reset to go off. In the United States, our elevator buttons don't go off when we push them a second time. Although I could have also built a circuit like that, but that's not what I'm used to. In other countries, apparently, when you push a button twice, it goes off the second time. How about that? Neither here nor there. So the question is how to do 80+ latching circuits. And on these pictures I have of the ELF panel, you can see that they used an Omron latching relay times 81, which is totally a reasonable solution, except expensive because those Omron relays are $10 to $20 a piece. Times 80 is, somewhere between $1,000 and $1,600 to populate this. There is a cheaper way. I called my friend Zach Ratting. He has been on the channel before and worked with me on some other things here on Tested. And he is Zach is kind of what I am in the making of things in terms of the physical. Zach is, actually, I don't know his specific making skills, but his electronic skills are like as broad as my making skills. He understands this stuff at a very deep level. And so he drew up a circuit for me and gave me some parts to populate it with. And here is the circuit. This makes me so happy. This is the model of the latching circuit. And we're using these little tiny PCB elements, which I couldn't even believe they were that small. There, that. Wait. Yeah, there we go. There's one. Dude, I didn't even know I could solder that small, but I can apparently. Anyway, we got this working. And the question is, am I going to build 81 of these? I was ready, and then Zach explained that I didn't have to because he could draw up that circuit and send it to JLC PCB. They are not sponsoring this. I know that JLC PCB has been out there sponsoring a bunch of maker builds, and this one isn't sponsored by them, but they are the clutch provider for this project because Zach was able to build a PCB board on his computer and send it to JLC PCB, and they sent back 10 of these 16-channel latching circuit boards. So this is 16 separate latching circuits, and we bought 10 of these, populated with all the electronics, the resistors, etc., for less than $100. I only need 5 boards, so we have a 1-to-1 redundancy. I need 5 boards, I have 10 boards. This is crazy to me that you can get this done that cheap, that fast. Also, it arrived, I was away, but it arrived in like a week. This is a brave new world, as far as I'm concerned. I know that some of you out there have been dealing with this stuff for a while. To me, this is like science freaking fiction. But so, Zach is coming here today to help me wire up the first switch and just get a test going. And then once that happens, he can go home. I will then spend probably 15 hours or so doing all of the wiring of 5 boards worth of 16 channels to get this thing going. We are on the home stretch here. This is the last big piece alongside the hanging technology. Yeah, it's really exciting. So the next step is Zach comes, we wire it up, we test it, we make sure it works to our satisfaction, and then I go and do some wiring. Dude, can you believe this? Crazy.
So, I mean, you could do it 2 ways. You could actually drill and bolt these on, or you could just double stick tape them on.
Well, I figured just for our test we can double stick tape. I am going to bolt them on.
Okay.
Yeah.
I mean, the double stick tape is actually nice because it does give you a little bit of a spacer,
Oh.
and you can just shove the wire through and still be soldering. It's not a bad,
All right, I'm totally fine
but
with that.
whichever.
I'm running out of smaller batteries.
And you have, I think, twice the amount.
But
that
yeah,
you
I only need 5.
But
And I don't think I'm connecting any of them to these guys. I think these will be just lit.
okay.
Also, I figured out animations. So, this is for future.
Yeah.
But falling snow, falling rain, splashing animations. But then I was like, fucking Tetris. I can have the shape show up in the top 9 and play Tetris with the door open, door closed buttons. And then Pong, I could play Pong.
That would be really
I
nice.
love the idea of layering in extra.
Yeah.
I could do a shadow.
Yeah.
I could have a camera and have it be your mirror.
Yeah.
Oh, this is so awesome. Or even run everything through the backside and string relieve it back there.
You could also, actually, yeah, if you run them around,
Yeah.
that'd be hot. Just keep it. We can this is, I guess, the top one. This, well, how'd you have it in? You had
I have it
this
there,
way.
but I mean,
It's
we'll
fine.
just clamp it.
Doesn't matter.
Here.
So we have to decide just the routing of all of this. If this is going to go under, like under the next one, which
Right.
probably makes a lot of sense. It comes down, does like a fold, comes down here.
And deals with these 16.
It could be.
So it could be that the farthest one it needs to get to is there.
Or because it's top, does it make sense to go all the way back up?
Oh.
Probably does.
Yeah, it does.
Yeah,
You're
yeah.
right. So then it's up to here, over to here, up,
And then,
And then-
sort of to
to the last mile, right?
well, but which is for yeah, which
It feels given that that's the last mile and so is that.
give yourself another 4 inches and
Yeah.
then because again, if you have extra wire back here, it's not the end of the world. Snip, snip, snip a bunch.
Those scissors, these clippers, I'm getting rid of them. They're slightly shitty.
Yeah.
Oh,
all
we
right.
get an apple box. Oh, but we can take that one and wire it to the bottom just for our test.
Sure, we can wire it anywhere. So we'll just get used to what the color codes are.
And
So
I would
it's
follow them.
yeah,
Yeah.
because it's like you can see LED is blue and then the corresponding is green.
All right, so this is the first switch.
Yeah.
Switch LED pair.
Yep.
Oh, right, and we need a line going to, a
So-
ground line going to that same switch.
Yep. And then we'll also need power and ground to the board.
Right. Zach has just left, and we successfully wired up one of the board switches to the L button, and watch that. Oh, it's on! And reset is the alarm button. Doink. Oh, yeah! Dude! Very, very exciting. So, there are many steps between now and completion. So there's going to be a lot of time lapses. That's all I have to say. Time lapses, here they come. This is a lot. This job is a ton of crimping. 82 times 4, which would be 328. There we go. So 328 separate crimps on as many pieces of wire. And look, I wanted to talk a little bit about tedium, because one of the specific skills that model making requires is an ability to tolerate tedium, and not just tolerate it, but like execute it. It's like tedium is the job. On something like this, every connection matters. And it's really easy to get bored and to lose focus during stuff like this. So personally, for me, as I'm doing this, I'm often asking myself, like, oh, is there a more efficient way I could grab each pair of wires so that I'd have more access? Could I set this up in a slightly more efficient way? I'm always looking for small improvements in time. And one aspect of that is that it's a nice efficiency, because occasionally I find I come up with ideas for making something go much faster. And I've talked in the past about the pitfalls of many. This is 80 some odd switches with multiple operations per switch. And what that means is, like, everything that you've got to do is times a whole intense time factor, right? Like when you have 100 of something to do, if that takes a minute, that's almost 2 hours right there. 1 minute per. And by the same token, when you're doing many, every bit that you can shave off each transaction, each time apart, each touch you do to the parts that you're working on, each time you can reduce a touch, you gain time. So on one hand, it's mathematically nice to be asking yourself if you could do better, because sometimes you can and you benefit from that. But then the other thing is that it keeps my brain sort of flowing and paying attention to the task at hand. And I want to tell you, I woke up this morning and said to my wife, oh, today is the holy tedium. I love this kind of work. I find it really meditative. I find the reality is that when you have a lot of something to do and you look at the two piles of things in front of you and you realize at a certain point those piles will be brought to zero and you'll have done it all. And in the middle, you're looking at the piles and you're like, I don't feel like I'm making any progress. And then you do. And then slowly, inexorably, those piles get smaller and you do make progress. And honestly, that, no matter how tedious you think something is, it's always going to go a little faster than you think when you get to the end. You'll be like, that wasn't as bad as I thought it was going to be. This whole elevator panel is nothing but that kind of marvelous tedium. Yeah, the board's wired up. The board is wired. All the right leads are going from the board, and now it's time for me to put it here and start to hook it up. That's really the next frickin' thing, isn't it? Yes, it is, Brad. Yes, it is. So what I'm going to do is I'm going to put the board up here and I'm going to start to label some of the wire bundles coming out of this so I know which they are. I've got this divided into 5 zones, 1, 2, 3, 4, 5, 16, 16, 16, 16, and 15 switches respectively. Yeah, that's where we're at. Hey, everybody. All right. When last we left our intrepid hero, I was wiring up all of these boards to power up all of these buttons. But we found a flaw. There was a flaw in these boards. And as part of this, I had reached out to Tested's own Jeremy Williams and talked to him about the potential for adding some low bit depth animation using this low bit depth screen that is the elevator panel. One way of looking at the lights of the elevator panel is that they are a grid, so they could be considered pixels of a screen, a very low resolution screen that is 5 by 17. You've heard of 640 by 480. This is 5 by 17. And I was always clear that was like step 2 of this process was to add animation. Step 1 was to just get all the buttons to function. And by function, I mean go on when you hit them, and then you can reset them and turn them all off again. But later on, I want to do some other fun stuff and maybe even some Arduino programming. So Jeremy Williams looked at the buttons and was like, hey, what about, he said, hang on. Let's look at the button here. So here is the elevator button in question. And here is the light panel here. When Jeremy and I talked about turning these things into pixels for animation, what Jeremy was saying was about, addressing them, we could change their colors. And I was like, how do we change their color? I mean, I already added a yellow gel to these to make them look more incandescent. And he was like, no, we could put in like addressable LEDs. We could use RGBW, like RGB and white LEDs potentially to create whatever color we want, and we could address to them. Well, when Zach and I discovered that there was a fatal flaw in the boards, that's what we did. So Zach designed a new board. Let's see here. Hold on. I like showing examples. So this is the old board. This is the new board. We only needed 5 of these. We need 83 of these, and we have them. Et voila. There she blows. And the best part is we were able to order this from DCP, what's the name? JLCPCB. We were able to order this from JLCPCB in, like, again, just a couple weeks. So that is an addressable LED, and I'm going to be jumping from each LED to the next. I have to remove all the old bulbs. And so, yeah, there's going to be some time lapses. Look, we're already in the Footage Hall of Fame on this episode, so I may just shoot this as a time lapse, literally, instead of free rolling. That may be what I do. Here we go. There's a couple of lessons in here in what I just did. So I've talked a lot on the channel. Let's see. That's the better view. I've talked a lot on the channel about the tyranny of many. When you have a project with a lot of individual components to it, each component that needs attention and attachment, you will find that you can get into the deep weeds insanely quickly with things that need to get done, and you don't have enough time TM to get them done. And so one of the things I noticed and talked about early on in this video is that the buttons, in order to be placed close together, are actually placed in a oscillating horizontal vertical arrangement. You can see it across the back here. A horizontal and vertical arrangement. And when I did that, I think I said this on camera, I made sure. So there were 2 states, there were 2 positions. Actually, when you have switches like this, each one of these can have one of 2 orientations, right? Its own orientation and 180 degrees off that orientation, which means that across all the buttons, there's 4 different rotations that are possible with this light panel. But when I set it up so that there were only 2 orientations, that the light panels were either with the logo on top or the logo on the left. Is that correct? It doesn't matter. I reduced it to 2 orientations. I might have even said this in the beginning of the video. I did that for basically what just happened that I didn't expect, which is I had to take out all 81 of those switch panels. And because there was only 2 orientations, I didn't need, you can see this in the time lapse, I speed up. I didn't need to like look at each one and figure out where the tab was. It was always either here or there, here or there, here or there, here or there. And just that little bit of efficiency saves me minutes, which means at the end of a job, it could save hours. And I just wanted to point out that like, that's my institutional knowledge coughing up out of my gut to say, there's all sorts of metaphors, to say, hey, reduce the complexity of this. It may help you later. And the answer is, it really did. Now, the other thing that I'm doing is I'm replacing 3 of the switches. I don't know about you, but regularly every day I get enraged about bad user interface. Every website where I can't figure out where to click, every point of purchase self-checkout, user experience is in a rough state culturally. I really believe that. And I think one of the most egregious violations of UX design are these guys. Yeah. You recognize them as the door open and door close. Pop quiz. Which one is this? Which one is this? I have to look every time and be like, wait, the triangles are facing out. That means open. On the original elevator, there is no such issue because this were the 2 buttons on the original elevator. And I submit This is way, 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 way big Reynolds Graham's number way more readable than this malarkey. Can we just do away with these forever? I hate these. I hate them. I don't like to use the word hate, but I hate these. Okay, so I'm replacing these, and also on the original, the alarm button was written as alarm. I just swapped it out. Here is the old one and the new one's in there. Okay. Everything's been pulled out. It's now time to solder. So what I have I have a whole bunch of these. Those are the new light panels. And I've got to solder on some little connectors onto each one of them. So once I get this table cleaned up, that's the next thing I'll do. And I'll set up a different time lapse for you. It works! Reset. Set it all up. Oh my gosh. Oh, so satisfying. Dudes. Oh, so excited. Sorry, it's like Saturday morning and we finished this last night. Zach Radding did the final programming. I did all the wiring. I can't remember if I've said this on the channel before, but my understanding of electronics is structural, not philosophical. Like, Saturday morning hair. Electronics not my strong suit. I don't have any formal education in it, and the kind of brain that Zach Radding brings to electronics is just something I fundamentally kind of don't understand. But I'm learning computer. I'm learning computer, and Zach kind of he sort of held my hand and walked me through the prairie of wiring, wiring a matrix. That this is a simple 8x10 matrix with 8 rows and 10 columns. And as long as you have a diode at every switch, the computer can tell by the cross of that grid which switch was pressed. There was some very, very funny failure modes last night where 2, 3, 4, 5, 6 lit up, but 7 would light up 11, 8 would light up 10. Like every other row would go backwards. And that's because of the sort of wandering peripatetic way I did the jumpers on the backs of all the LEDs. But it only took Zach about an hour to find the right color, and I love this color. This color feels good. And you know what this means now? Now I get to peel off the protective paper. Yeah. I had shop beers last night with a bunch of local shops and some shop friends, and everyone was asking. First of all, we all played with this. Second of all, everyone was asking me, can we peel off the protective layer? And I'm like, no, I have to do it on camera. And they're all like, yeah, that checks out. All right, so here we go. Oh, baby. Oh, yeah. Oh. Oh. All right, come. Come on, let's try and get it all at once. Might not be possible, but should be. This is the kind of part of the construction job that I'll bet is really fun. Like at the end, once you've set up a whole office building. Oh, come on, stop failing. Even Kevin Binkert, who actually cut out my, Kevin Binkert, who did all the water cutting on the stainless and all the stud welding for holding the switches in the back, he came last night and got to play with this too. That's really, I like that. Little tiny remnants in it. Oh, I made it. I've always wanted to do it. So what happens now? I can't remember if I've talked about this in this video yet, but I'm gonna go put this up in my house. This is part of our Christmas decoration. Yes! Isn't that awesome? Yeah, I just got to put together a little toolkit, a level, screw gun, and then, yeah, we'll have a finale shot of this in situ in my house. So freaking satisfying. One of my favorite prop replicas ever. This would not have been possible without local vendors like Kevin Binkert at SMP, my friends like Zach Radding, Dupar, elevator button makers extraordinaire for giving me a great discount on these buttons with their 7 million presses before failure. It's been an education. And that's the best part of any of these builds, isn't it? All right, I've gone on long enough. To the install! There she blows. It's Christmas everywhere. Oh. Thanks you guys for joining me for this holiday build. Even though this might go up after the holidays, it's a holiday build. Thanks for sticking with me all the way. See you guys next time.